Hello there, my name is Jeff Woolsey. I'm a Principal Program Manager in the Microsoft Cloud and Enterprise Division. It's a pleasure to be here with you in this conference, and today I want to talk to you about data center fundamentals. I'm going to tell you right off the bat, there is so much coming in the next wave of the 2016 wave, whether it's Windows Server, whether it's System Center, whether it's Azure Stack, whether it's Azure, that literally I could spend the next few days here and still barely be scratching the surface of what we're delivering. So what I'm doing today is I'm going to really go after some of the high-level scenarios and talk about some of the high-level features, but really cover some of the core things that are important for data center fundamentals, and really explain to you how the things we're doing in Azure affect what we're doing on premises, and how we're giving you that same technology, that architecture, that value, those learnings coming to you, and how we want to make the IT pro more valuable, more productive than ever, how we want to make the developer more valuable, more productive than ever, and we're very excited about that. So let's get started. The first thing I always like to do, and I'll spend a brief amount of time on this, but it's really to explain how we think about the cloud at Microsoft. Because what I find is, depending on who customers talk to, they'll get a very different answer for what cloud really means and how they can be thinking about it and how they should be embracing it. One of the things I always start with, of course, is why people are interested in cloud. I'll never forget that a few years ago when we started talking about cloud initially, people said, why do I want to go to the cloud? And I think as a whole, the industry kind of responded, well, it'll be cheaper, right? That's kind of our natural reflex, is to go with, oh yeah, we think it's going to be more inexpensive. And that's certainly a key component of cloud, but it's actually not the main reason why people are going to cloud. Something we've seen, and in fact this has been confirmed by numerous analysts, including our friends over at Gartner, is that we find that agility is actually the main reason why people want to take advantage of cloud. The fact that I could use complex services that, yeah, I could build Hadoop infrastructure on premises, I can deliver machine learning, I can try and build and manage all of these things, but I may require a huge capital investment, whereas with using Azure, for example, it could be a couple clicks and guess what, I'm ready to go with machine learning and Hadoop. So agility is a key part of this. For the IT pro, this actually means you can actually deliver more services for your organization and deliver these things faster than ever. And I'll explain more into that. So very briefly, when we think about Microsoft Cloud, we really think of it as three legs to a stool. And it starts on premises with the private cloud. In the private cloud, for us, Windows Server is our platform and System Center is our management. But the really point I want to make here is I can easily describe the private cloud in one word. And that word is control. Very regularly, I'll talk with a customer that will say, you know what, Jeff? I've got a workload that has to run in a German data center on German soil by German citizens. Are you going to try and force me to do something? Force me to run into Azure? And my answer is always absolutely not. This has nothing to do with engineering. This has nothing to do with technology. This has to do with data compliance, regulatory, and even data sovereignty. If that's the case, then private cloud is exactly what you should be doing. And we're happy to do that today with Windows Server, System Center, Azure Pack, and more. At the same time, we've been making huge investments in our public cloud in Azure. With Azure, we offer platform as a service, software as a service, and infrastructure as a service, and so many more things than just VMs. In fact, one of the things that I realize people tend to get fixated on is cost per VM, which I think is honestly kind of silly at this point. Virtual machines are so inexpensive and so cheap. You know, we're talking pennies to run VMs now. What you actually should be looking at when it comes to the public cloud is not just the VM, and in fact, IaaS put off to the side. What you should be really considering are the greater services that can be delivered from the public cloud. Like I mentioned before, Hadoop, machine learning, ways that you can improve the security, ways that you can improve the management, ways that you can do things faster with more agility. And when it comes to the public cloud, I can describe that in one word as well. And that word is scale. Let me give you a perfect example. Last year at the Sochi Olympics, we helped to deliver the Olympics worldwide to over 100 million customers in 22 countries across 4 continents. And guess what? It just worked. And it showed off the power, the elasticity, and the agility of the cloud. And what I mean by that is we were streaming worldwide. And in fact, during the USA-Canadian hockey match, there was, for the bronze medal, it started off with this many people watching, and it kept growing and growing and growing until we reached all the way up to 2.1 million people actually watching the hockey game live streaming around the world. And when the game was over, it scaled back in to the number of people watching the next event. And we're allowed to do this with elastically through Azure. And the whole point of a public cloud is about delivering at massive, massive scale. Finally, the third part of this is we look at service providers. Service providers provide customization and reach. And what I mean by that is every so often someone will come to me and say, Jeff, Azure looks fantastic. I have this workload that I'd like to put in a specific server in a specific Azure data center in a specific rack. Can I do that? I'm going to give you a key and I'm going to have a key. Can I do that type of scenario? And unfortunately the answer is no. And the reason why is real simple. In Azure, we deploy the minimal footprint is 1,000 servers. We don't think a single server or even a single rack at a time. That's just too small a scale unit for us. So if someone needs that level of customization for a service level agreement, guess what? We've got a cloud OS network literally around the world where customers can take advantage of that. The reason why I bring this up is because depending on who you talk to, you're going to get a different answer for cloud. Some may say that cloud is only if you run it on premises and it's a private cloud. Some may say, no, it's only running in public. Some may say, oh no, it's only running with a hoster or a service provider. When we look at the cloud, it's actually all three of these. It's not one or the other. And in fact, the vast majority of customers that I talk to tell me every day, you know what, the thing that's most important to me, Jeff, is hybrid. I want hybrid so bad I can taste it. I want to take advantage of the capabilities of Office 365, of Azure Active Directory. I would love to be able to do disaster recovery and replication up to Azure. At the same time, there are some workloads that I want to continue to run on premises. I've had CEOs tell me, you know what, there are some workloads that are so critical, there are secret sauce, that we literally want to be able to touch those servers every night. Fantastic. We're not going to change that. We're not going to tell you you have to move any of that to the cloud. The important thing is giving you a hybrid model and giving you the model that makes the most business sense for you. That's how we think about the cloud. So to do that, of course, we need to provide a consistent model. And what we've been doing for the last couple of years now is doing that through the Windows Azure Pack. Windows Azure Pack is a perfect example of us taking code directly from Azure. We actually give it to you. You can run it for free. And Azure Pack plugs into System Center into Windows Server. And we provide this so customers can do this for private clouds, and service providers can provide service offerings that look and act very much like Azure. The feedback has been overwhelming. Customers have told us, oh my gosh, Jeff, this is what we're looking for. We have IaaS virtual machines, we have platform as a service web services, SQL Server, MySQL, all being delivered on premises under my control, but giving me a cloud experience. So it's been a tremendous learning for us. But at the same time, we've also learned one very important fact. Customers have told us Azure Pack is great, but Jeff, we've noticed that Azure Pack is Azure-like. It's Azure similar. It's not Azure the same. And what I really want is Azure the same. And the reason why is because when I tell my developers to write the next generation cloud services that are important to my organization, I want them to be able to write to the same APIs if they're on premises or in the public cloud with Azure. So guess what? That's exactly what we're doing. And that's why we're introducing the Microsoft Azure Stack. Azure Stack is about bringing Azure on premises so that you can run it in your data center. It's about bringing our learnings, our technology, Azure code, and most importantly, giving you a platform so that developers can write to the Azure resource model, and that application can run on premises, in your data center, or in the cloud without any code change. That is flexibility. Now when you couple that with cloud services, we're giving you the best of all worlds. So, one of the other interesting challenges that comes up is people look at this and they go, Jeff, this is great. I actually do have public cloud services that I'm using. Maybe it's from Azure, maybe it's from AWS, and maybe I have multiple private clouds and multiple data centers. The challenge becomes is how do I manage this? And customers have already told me many times, Jeff, managing a single data center is already hard enough. We don't feel like we're doing that well. You know, we can do health monitoring of the platform, and we've got some health monitoring for our critical services, but it's hard to do the entire management and be able to get the intelligence that I need to make sure that I'm actually improving my infrastructure and be able to do that in a cohesive way, and be able to do that across data centers is something that just seems like it's impossible to reach. Well, one of the things we want to do to help make that even easier is to deliver you that consistent management experience as well. And that's what we're doing through the Operations Management Suite, through OMS. And the important thing I want to point out here is you don't have to be using any public cloud resources. If you're just using private cloud today, you can still take advantage of OMS right now. And OMS is available right now. This isn't something that's shipping later this year. This has in fact already been shipping for almost a year, and it's a fantastic resource. Think about it this way. In Azure, we have to manage millions of physical servers, running tens of millions, if not hundreds of millions, of workloads and services on top of that. How do we manage it? Well, what we're essentially doing is we're taking that console and flipping it around so that you can use it to manage your infrastructure better, whether it's on premises, whether it's in public, whether in service provider, or whether it's all three of these. And it doesn't matter if it's Windows Server, if it's Linux, if it's VMware, if it's Hyper-V, or if it's Azure, or if it's AWS. It's about providing that consistent experience. So I'll get more to that in just a second. The important thing to point out is at the end of the day, our goal for cloud is real simple. We want to provide you the best cloud whenever and wherever it makes business sense. Now again, I'm not going to force you into any one of these. We're going to give you all options and let you choose what makes business sense for you. Now, one of the things I already mentioned was people tend to focus on infrastructure as a service when we talk about public clouds. At the end of the day, this is a perfect example of why you should be thinking much more broadly and looking at more of the public cloud is what is the ecosystem around it. Take a look at what we have here in Azure. If you see here, you'll notice, yeah, virtual machines, it's just one little square up here in the corner. But what if you want to do things, for example, you want Hadoop, you want HD Insight, you want machine learning. Sure, you could set up Hadoop, you could buy a bunch of servers, a bunch of storage, a bunch of networking, machine learning. You could buy racks and racks of servers and try and configure and set it up, and maybe many, many months later you're ready to go. Or more importantly, this is already waiting for you on Azure right now. And if your developers want to be ready to start writing their applications and more importantly, figuring out how do we get our organization, our business to the next level quicker, you can take advantage of this right now. As an IT pro, one of the critical things is understanding how you can help in providing these services and making sure that you've got the right services on-prem, the right services in the cloud, and that you can enable your developers to be more agile. At the end of the day, being the IT pro who changes disks out or fixes network cables is not where you want to be. If you want to have a long career, you're going to be a hybrid IT pro. The guy that actually manages on-prem as well as in the public cloud. That's going to look fantastic on your resume. A couple of other things to point out. Security. Security is something that comes up relatively commonly when I talk with customers about the cloud. And they look at it, is there a way that the cloud can actually help me securing my infrastructure? And a perfect example of that is multi-factor authentication. And in fact, multi-factor authentication is something we use here at Microsoft, and I see it regularly. I'll give you a perfect example. I'll be sitting on my couch at home with my personal Surface, and I want to get access to some SharePoint sites internally that are up on Office 365, and I'll type in my domain, my credentials, my account, all of the information, but it's not a domain joined Surface. It's a private machine. It's not domain joined at all. So even though I've typed in the right creds and password, it doesn't recognize my machine. So it says, look, I just want to verify for sure that this is who you are. So I'm going to send a second form of authentication, and I'm going to use it using your phone. And so this is maybe a 10-second process. I get a call on my phone, I type in an additional PIN, and it ensures that it's not someone trying to break into my account remotely, but I'm able to actually confirm, no, this really is me, and I really am trying to access these SharePoint resources available on my personal Surface. This is just one of many examples. Azure Active Directory is another one. This is something we knew initially was going to be popular. We didn't know just how popular it was going to be. Last time I checked, I believe it's easily over 500 million accounts that are being federated between on-premise and Azure Active Directory. And this goes to helping secure your business, helping secure your organization, and creating a consistent authentication model. Think about the simple case where someone joins the business, you get them set up in Active Directory, and sometime down the road you want to give them access to cloud resources. Maybe it's web pages, maybe it's SharePoint, maybe it's mail, and other services that are available. Well, maybe a few years down the road they decide to leave the company, and guess what? When you disable their account, this is going to also, because it's federated up in Azure, it's also going to give you that. It's also going to give you the peace of mind by being able to disable those accounts and those resources available in the public cloud as well. So it's help making sure that we're providing an easy way to manage in a hybrid scenario. Now, I mentioned agility before, and one of the things I want to point is how we're providing agility for folks that are on premises and what this means and what we've learned from Azure. What you see here are just a few features we've delivered over the last 12 months. And again, this isn't a full list, it's just a few of them. But the important thing to understand is that we're able to deliver features faster that you can consume on premises. Let me give you a perfect example. The way we've been running, the way software has been delivered for the last many decades is we deliver you a copy of Windows Server and maybe System Center, and then a couple of years later, we give you a new version and there's an upgrade process, there's a migration process. Maybe we go through some training, maybe we give you some PowerShell scripts, but we try and help you and ease you through that process and upgrade you through the various versions. In the Azure world, this very much changes. So for example, I could be logged into Azure and I could be doing, for example, managing my disaster recovery with my on-premises environment and managing my Hyper-V replica. And you know what, it's a Friday afternoon, I go home, spend some time with the family, go check out the movie, get some dinner, come back in on Monday morning, log in, and guess what? There's 10 new features there. I now have new features for backup and replication that will help me protect my company with better agility, and guess what? There was no migration process, there was no upgrade process, there was no process at all. We literally lit this up on the back end in the cloud, and you're able to do more faster. It means you're able to deliver more value. That's what we really want to be focused on. So now what I want to do is I really want to drill into how we're delivering these things on premises. I've spent some time talking about Azure because one of the things I want to continuously reinforce is even if you're not using Azure today, we're delivering you Azure features, Azure capabilities, Azure value, and our learnings, whether it's architecture, whether it's code, on premises. Nobody else can say this, and this is an important factor because it helps us make sure we're delivering the right thing and maintaining this consistency in the public and in the private cloud. So as we look into the 2016 wave, we really are taking a cloud-first innovation approach with infrastructure and application platform. Let me give you just one brief example, networking. I already mentioned the Sochi Olympics, and in fact, the fact that we streamed literally around the world to 100 million users, something we're very proud of, and literally it just all worked. Well, one thing I've had customers ask me about is they go up into Azure and they see, wow, you've got a bunch of really interesting networking features. Software load balancers, network controllers, distributed firewalls, virtual machine chaining, and literally a litany of all of these fantastic software-defined networking capabilities. And I've had people pull me aside and say, Jeff, that's your secret sauce. That's something that makes Azure special. And that's probably something you're going to keep in Azure, and you're not going to give that to me on premises because you're going to try and push me up into Azure, right? And my answer's always been, no, actually, that's not the case. We just haven't gotten around to bringing it on-prem yet. Well, I'm thrilled to say we're doing that in this release. The 2016 wave is bringing a whole host of Azure-inspired features and capabilities on-prem. That network controller in Windows Server 2016 in Azure Stack. The distributed firewall, the software load balancer, virtual machine chaining, things that have already been tested at massive worldwide scale. Guess what? That's coming into the box on premises now for you. This is part of our ongoing commitment to deliver these new features and capabilities on premises for you so that you can take advantage of it. And software-defined networking, that's a many-hour conversation in and of itself, but that's just one brief example of how we're delivering that on premises. So, how are we doing this? Well, if you look at Azure at a very high level, there's cloud infrastructure, there's infrastructure as a service and platform as a service services, and it's available through our portal. And then there's a bunch of services, and this is just a few. Again, I showed you a screen full of them just a moment ago, and in fact, even that wasn't a full list. That was a shortened list, an abbreviated list of all the services we have, and we're constantly adding more. And that provides services up for Windows Server and Linux. So, that's kind of what it looks like today. If you compare that with what we're doing in the Microsoft private cloud, our private cloud today, as I mentioned before, consists of Windows Server, System Center, and Azure Pack. Again, people have given us the feedback, this is great, but it's Azure similar, it's Azure-like, it's not Azure the same. So what we're delivering in this next generation is actually bringing Azure on premises and delivering that as the Microsoft Azure Stack. Now, one of the questions I always get asked is immediately as people look at, they go, wait a minute, stop. before you go on, Jeff, why did you do Azure Pack in the first place? Why didn't you go right directly to Azure Stack? Which is actually a really great question. And it goes back to something I mentioned earlier. When it comes to Azure, technically we could have probably given you Azure a few years ago and said, hey, guess what? You can run this on premises. But as I mentioned before, when we deploy Azure, it's a minimum 1,000 servers at a time. Guess what? That's a scale unit that most people aren't going to be readily able to consume. So with Azure Pack, what it did was we went down this road to figure out, A, was this the right path? Were we doing what was important to you, and were we delivering the right strategy? And you overwhelmingly have told us, yes, this is absolutely the right thing. And now what we really want is more than Azure-like and Azure similar. We want Azure the same. So what we've been doing and what we are delivering is delivering an Azure Stack in scale units that you can consume. 4 nodes, 8 nodes, 16 nodes, 50 nodes, 100 nodes, 500 nodes, etc. We want to make sure that we're giving you that experience that you can consume at much smaller scale units, but also be able to scale up to much larger scale units as well. So that kind of explains how we've gotten to Azure Stack. Now, as I mentioned before, one of the most important features and aspects of Azure and Azure Stack is this application consistency. What I really want to be able to do is tell a developer, look, I want you to write an application that's going to last 10 or 20 years. And by the way, this model, I want this to be extendable, flexible, and I want this to be able to run on premises in the public cloud without any code change. Well, let me give you an example and just show you what this, an example of an application. This is actually a screenshot from a demo I did back at Ignite quite a while back in late last year. And here's an application that we actually deployed, and you can see I've highlighted here. This is actually running in Azure. And you can see this application consists of a number of resources. It consists of virtual machines. It consists of network interfaces, public IP address. It actually consists of a PaaS SQL database, and it even includes PaaS storage like tables, queues, and blobs. The important thing to understand is as you develop a modern cloud service, you're going to want all of these different features. It's not just virtual machines. You want to be able to mix and match virtual machines or PaaS resources and be able to plug all of these together. And in fact, more importantly, you want to make sure that this is a future-proof model. We've actually thought about that as well. Imagine 10 years from now, there's going to be some fantastic new technology that you're going to want to incorporate in your cloud service. And you're going to say, Jeff, I need feature foo in Azure. Well, the good news is we're already set for that. When feature foo comes out, it'll be pluggable and extendable. It'll just be, guess what? That's just another row in here. Because this is how we deliver Azure services today. We already deliver it to be extendable and flexible. So we future-proofed you for the new applications, new services that'll come down the road that we haven't even thought about, but at the same time giving you the ability to write on-prem, write in Azure, and be able to deliver in both places. So this application you can see is running in Azure. Well, what would it look like if we actually deployed this same application in your data center that you were managing on your premises? I'm going to warn you now, this is the most boring demo ever. It in fact looks exactly the same. Now you'll notice the URL is different. This is not running in Azure. This is actually running in Azure Stack in one of our labs. And in fact, you can see right here, this is the same application, the same virtual machines, network interfaces, IP address, PaaS, SQL storage, PaaS web, all of it's exactly the same application. So what this means is that flexibility to be able to write on premises, write in the cloud, or take advantage of where you want to run it. And in fact, one interesting thing I've had is people have been looking at this and I've been trying to understand what are the scenarios that they're very interested in. And one that has come up numerous times is people want to actually be able to develop a new application in Azure. They don't have to buy any hardware, buy any storage, buy any networking, actually do the development up there, make sure it works, and then they want to be able to deploy it on premises in Azure Stack so they can run it in production on their premises and manage it that way. So that's an interesting scenario that we've seen as well. And we know there are plenty more, and we are eager for you to hear that feedback from you. Which is a perfect time to mention that Azure Stack is available as a technical preview today. You can download TP1, and in fact today it's specifically for a single server, and the goal was really simple. We wanted people to be able to kick the tires on it. We want developers to be able to write against the APIs and start to understand how Azure Stack works. Now, I also mentioned the importance of management. And what is this? How are we going to manage all of this? Because if I have Azure Stack running on premises and I've got multiple data centers and I've got multiple public clouds, how do I bring this under one view so that I can do this most efficiently? And how can I actually take advantage of the cloud to give me insight to running my operations better? Well, that's what the Operations Management Suite is all about. This is available. You can try it for free, and it's available now. And I urge you, let's literally go in here, type an email address. It's literally a few steps, few clicks, and you're done. And just to give you an example of what this can look like, at the overview page, we'll provide a high-level view of a number of different things. For example, automation, site recovery, backup, security, and audit. I've had a number of people look at this and immediately see the Active Directory assessment and go, ooh, that's interesting. What's great about Operations Management Suite is because it's a cloud service, we are essentially taking data, we are running our Hadoop-based machine learning across this intelligence and using our analytics to provide learnings and to be able to update these assessments, these intelligence packs, and to be able to deliver more value and be able to do this in a real-time way. And in fact, you can also create these very customized. So if you've got someone that's very focused on storage or networking or virtualization or compute or security, they can create their own custom dashboards. And you can of course share these with these, and these of course can be managed through role-based access and control. But the important thing is it gives you a unified view across all of your services wherever they reside. And if you have custom applications that you've written, and of course, hey, you've got your own log files, well, guess what? We can ingest those so that you can, and parse those so that we can actually help you bring those under management as well, something that can be pretty challenging otherwise. So Operations Management Suite, something I highly recommend you checking out as well. And again, whether you're using the public cloud or not, this can provide you on-premises intelligence. And of course, this integrates with System Center. It integrates with your Azure Storage account. And again, this works for Windows Server, Linux, AWS, Azure, you name it. So now I'm going to shift to, again, a little bit more on-premises with storage. And one of the things that I get asked about quite often is people will go up to Azure and they'll see that we have this low-cost, fault-tolerant storage up in Azure that we deliver for literally pennies per gigabyte. And people ask me very often, hey, you know what? I'd like that too, please. I would very much love to have fault-tolerant storage on premises. Does Microsoft provide software-defined storage on premises? And the answer is absolutely yes. This is an area we've been heavily invested going back to 2012. In Windows Server 2012, we introduced our software-defined storage stack with the scale-out file server using a number of key technologies like storage spaces. And with storage spaces, for example, today, you can easily build a Hyper-V cluster, a scale-out file server that connects to a shared JBOD storage and provides you a fault-tolerant solution for storage. This has been available for a number of releases, 2012, 2012 R2, and customers have been very excited about this, and the biggest bit of feedback has been, Jeff, this is really nice, but we want to be able to scale this out to even larger deployments. And we know that Azure, of course, this is how Azure does storage, through software-defined storage, and we want to be able to look at even larger scale. To do that, we looked at this architecture and we said, okay, we're going to have to continue to mature and iterate on this architecture. So in 2016, we're taking our learnings from 2012 in storage spaces, and we're actually adding more with a new capability called Storage Spaces Direct. And this is a perfect example of us taking our Azure learning and bringing this on premises. In this case, basically, we removed shared SAS as part of, as the connection point to your storage. Essentially, to think of it at a super easy way to think about it is you've got a server, an x86 server, plug in some storage, plug it into your network, you've got storage. You need some more storage? Take a server, plug in some disks, plug it into the network. Guess what? Rinse and repeat. So with Storage Spaces Direct, you're getting fault tolerance to disk, to the enclosure, and to node failures. Again, this is standard x86 servers, and the fabric we're using is Ethernet. There's nothing special. We're not requiring any special switches or any special HBAs. This is, standard Ethernet. And in fact, we recommend RDMA. RDMA is something that's actually very critical for your infrastructure layer because it allows us to do a whole bunch more without impacting CPU utilization. Most people don't realize, but even with 10 gigabit Ethernet and trying to do what we're doing with the scale-out file server, we can easily consume a core or more. If you're trying to do this on 40 gigabit, we'll actually easily consume many cores. Well, if you're using RDMA, which is a capability we've had built into our platform, both in the Hyper-V and to our scale-out file server and in Windows Server, this means I can use 10 gigabit, I can use 40 gigabit with 0 additional CPU utilization. This is something that gets lost, but it's actually a very important feature that people should be considering when they're deploying their next generation infrastructure. Now, when it comes to deployment for storage spaces direct, we've actually looked at the two most common models, and we want to make sure we support them both. The first example is one that seems to be the hot buzzword these days in the industry, and that word is hyperconverged. And hyperconverged, essentially what you're saying is each one of those servers is running a hypervisor with virtual machines, and it's running the storage, all on a single server. And I know the hyperconverged is a cool word and all, but there's nothing magical about it. It really means I'm running VMs and I'm running storage on the same server. Now, hyperconverged is really nice for small to mid-sized deployments. You want to do 4 nodes, 8 nodes, 16 nodes, 32 nodes. Okay, I can get that. But as you start to get to larger sizes, 64, 100, 200, 500, even larger, you're going to want to consider a converged or a disaggregated approach, where you have separate tier of servers for compute and a separate tier of servers for storage. And the reason why is really simple. For example, at this scale, you may have a bunch of workloads that are actually compute bound. And you know what? I need more cores or I need more memory. So I want to be able to add servers to this higher level tier without impacting the bottom level tier. And so I can simply add more and scale that up. Or perhaps my workloads aren't compute bound, but they're storage bound. And I need more IOPS or I need more capacity. Then I can simply add more storage at the scale-out file server tier. So this gives you the flexibility to scale each one of those tiers independently. And again, the hyperconverged one, don't get me wrong, it's a great one. In fact, again, for these smaller configurations, it's nice. But keep in mind that each one of those nodes has to be the same. Okay, if you deploy 4 nodes and 8 months down the road you decide you're going to deploy another 4 nodes, but you put in half the number of cores or half the number of memory or a different configuration of storage with different I/O characteristics, trying to make this scale in any sort of linear way, good luck with that. So, hyperconverged is great. You just got to make sure that each one of those nodes is exactly the same and that you really cookie cutter that every time, or you're going to have scalability problems down the road. Whereas converged disaggregated approach gives you the flexibility to be able to add a little bit with more flexibility. But again, we're going to support both of these models because each one of them has its pros and cons and makes a lot of sense. Another thing we're doing in terms of storage is delivering on storage quality of service. This is an area, honestly, I'm really excited about. We began a bunch of this work in previous releases of Windows Server and in Hyper-V, and now we're really delivering on the greater promise of delivering cluster-wide quality of service. So the scenario is pretty straightforward. Imagine you're running your infrastructure and you're running 50 VMs. But you know what? One of these is my SQL Server, or 2 of these are my SQL Server, and guess what? These are important. These are the ones that are mission critical to my business, and I want to make sure they're never starving for I/O. So what I can do is I can say, you know what? This SQL Server at a minimum gets 10,000 IOPS. It means it's always going to get that 10,000 IOPS, and in fact, I'm going to make sure it's never starved of those resources. At the same time, I've got a print server in here too. You know what? If someone has to wait an extra second for something to print, that's okay. I just want to make sure that my print server is something that's never consuming or has a high priority in here. So I could actually max that out and say, you know what, the most you ever get is 100 IOPS. Okay, just a couple of rough numbers here. But you get extreme granularity with our storage quality of service. You can set policy per virtual disk, per VM, per service, or per tenant. And so it gives you the ability to define minimums and maximums. But again, this is cluster-wide. This isn't per VM or this isn't per host. This is actually across the entire cluster. So this really delivers on some work that we started off a couple releases ago and now delivering it in its fullness in 2016. Another thing we're doing to make it really easy to get to Windows Server 2016 is delivering rolling upgrades. Now, we've had the ability to do seamless upgrades in the past, but it always meant you needed additional hardware. So for example, if I wanted to go from one set of servers to a new set of servers running a newer OS, I could always live migrate. We set the ability to live migrate forward. But in 2016, we want you to be able to actually take a 2012 R2 cluster. So you've got a 10 node server 2012 R2 cluster, and I want to be able to upgrade it in place to 2016 without requiring any additional hardware. So that's a brand new scenario that we're enabling. This has been a bunch of really great work in a bunch of different teams here in Windows Server. But I'm very excited about this because what it means is essentially we're going to walk through every node in the cluster. We're going to be able to evacuate all the virtual machines off of a server, take it out, essentially drain all of the virtual machines, take the node out, upgrade it to 2016, join it back into the cluster. So now I've got both 2016 and 2012 R2 systems running in the same cluster, and I literally walk through every node in the cluster, upgrading them all to 2016. Once I'm upgraded all of the servers to 2016, and by the way, the VMs on top, there's no downtime involved. They're being live migrated the whole time, so they're never experiencing any downtime. Finally, when all of the machines are up to 2016, I run a PowerShell command to upgrade the cluster from the 2012 R2 functionality level to the 2016 functionality level, and now I can take advantages of the other new features that we're delivering. And again, that's a whole host of a myriad of other new features that we're delivering in terms of resiliency, performance, reliability in clustering in 2016. But the important thing is we want to make it really easy so that you can get from 2012 R2 to 2016. Also, another thing I want to point out that we're doing in terms of storage is we're really continuing to invest heavily on the work that we've done with site recovery, with business continuity, and to disaster recovery. We were the first ones to introduce Hyper-V Replica way back in 2012 to incorporate replication directly into the hypervisor in Server 2012. And it meant you had an easy way to right-click on a virtual machine and replicate it to a secondary location. With Storage Replica, we want to also create and build on these scenarios even further. And the core scenario we're looking at is the ability to deliver stretched clusters. With Storage Replica, I could have a cluster running in New York, I could have a cluster running in New Jersey, and in fact what I'm doing is I'm actually replicating in real time synchronously so that all changes are being acknowledged in the remote location as well. So Storage Replica delivers both synchronous and asynchronous replication in the box. And the question I get asked all the time is, well Jeff, how do I make sure that I get synchronous? It really depends on the speed of your pipes and the latency that you have. As a rule of thumb, you can do synchronous replication up to theoretically about 150 kilometers. But I've spoken with a lot of people who have done this, and they say, yes, theoretically, that's how far you can go. But in real practical terms, most people tend to go up to about 50 kilometers. It tends to be something that's done within a metro. So that's kind of how we think about synchronous. If I wanted to do, say, Redmond to Seattle or Redmond to Bellevue, I can absolutely do that with synchronous replication. If I wanted to do Redmond to Chicago, that's a little too far. I'm going to have to go with asynchronous. The important thing to point out is both of these capabilities are in the box, giving you the flexibility to do whatever you need to do based on your business requirements and how much you're willing to spend and how much you're willing to invest in those network pipes between your different locations. Now, disaster recovery is something, again, I've mentioned we've been focused on very much, and we want to make sure we make it easy for folks to be able to deliver these solutions on premises, but also be able to manage these at scale. So one of the areas that we've been investing in has been in Azure Site Recovery and Azure Backup. And we want to make it really easy to be able to manage these things at massive scale. So when we delivered a Hyper-V Replica many releases ago, the feedback was fantastic. Customers said, this is great, it's easy to use, I can right-click on a VM, configure the replication, and literally in 60 seconds, I'm replicating a VM to a secondary location. But then the feedback became, well, Jeff, this is great, but I've got a data center in Seattle, one in Los Angeles, one in New York, one in Paris, one in Tokyo, one in Sydney, and I want to be able to view all of my replication, all of my runbooks, and be able to see this all from one console. And by the way, I still want this to be easy. So we looked at this, and the easiest way to do it and the way to provide you a consistent management experience was to actually use Azure. With Azure Site Recovery, we have a console up there, and because it's delivered as an Azure service through a browser and HTML5, I can actually configure and manage my site recovery through any device, like my phone, whether it's an Android device, iOS, PC, Mac, whatever, it's all delivered in beautiful HTML5. I can configure my runbooks, and I can manage all of this from a single location. So customers came back, you said, this is great, this is fantastic, but Jeff, this is a Hyper-V only solution. I have some VMware too, and I have some physical. So guess what? Remember that agility I talked to you about earlier? Well, this is a case where you went home on a Friday, you came back in on Monday, and by the way, we added a couple of drop-downs. And now you have the ability to replicate VMware and replicate physical machines as well. So we put more capabilities into the hands of our customers. And again, even if you're running just on premises and you're just managing replicating between your own data centers, we're giving you more features that allow you to do more faster. Now the feedback we got here was fantastic, which was, hey Jeff, fantastic, we can do all of this, we can do physical, VMware, and Hyper-V, but this is still between two data centers. And the feedback was, A, I don't have a secondary data center. We can do that, it's a $100 million investment we're not ready to spend. Or the other thing was customers came back and said, I have a secondary data center site, which costs me a boatload of money. I would love to be able to retire that. Is there another option? So we said, fine, we'll give you that other option. You can use Azure as your target for replication. So now you can use Azure Site Recovery, again, the same console, and be able to replicate this directly up into Azure and use that as your secondary data center. And again, folks said this is great for Hyper-V, but what about VMware and physical? Well, guess what? Just like before, you went home on a Friday, you came back in on a Monday morning, and we added additional new features, and you're ready to go. So think about, again, the agility, the flexibility we're delivering, and we're doing this in a very, very fast model, allowing you to do more. So I've been talking a lot about some core data center features. I've talked a little bit about storage. I've talked about some of the investments that we've made in Azure networking and how we're bringing SDN on premises. By the way, that's a multi-hour conversation in and of itself. But one of the things I really wanted to get into was security. Security is something that comes up in every conversation, and for good reason. If we look at what's happening in the industry, one just needs to look, seems like on a daily basis, there seems to be something new. The OPM hack, for example, the Office of Personnel Management, the IRS was hacked. We all get frustrated when we read these things because we know the bad guys are getting, they're trying harder, they're working harder, and they tend to be doing this, across continents, and they feel pretty safe doing this. And so we've got to continue to raise the bar. We look at security as something that's never done, just like performance and scale. We are constantly working on raising the bar. But if you look at just what's happening in industry, bigger motivations, bigger risk, there's just so much happening in the security space. Well, we continue to double down our efforts on security. And in fact, there's journeys that we started in releases before, things such as file classification, where we continue to add even more features and build on top of these things even further. There's stuff that we're doing up in Azure to help with security event logging, cloud-based security analysis, AD-based advanced threat analytics, and so much more. And security in and of itself is, again, probably a 2-hour conversation as a Kickstarter. The one I want to focus on today, though, is actually this first one, which is compute. Because this is something that's extremely valuable and can be extremely valuable to you running on premises to really help you in protecting your corporate and organizational assets. Let me explain this at a very high level first. First of all, I love virtualization. There's a reason I've been working on it for over 13 years. Virtualization is fantastic. It isn't perfect. As much as I love hypervisors and love virtualization, I'm also the very first one to tell you it is far from perfect. And in fact, virtualization creates two problems. And in fact, I could probably go back to sessions I delivered in 2005, 2006, where I said these exact words. The first problem is it creates a single point of failure. In the past, when you had a single server running a single workload, if the Exchange server went down or a SQL server went down, okay, it was bad, but it was a single workload. When you virtualized and all of a sudden you were running 20 VMs or 50 VMs and that server went down, you didn't just lose one workload, you lost 20 workloads or 50 workloads. Well, guess what? We all built high availability, we all built live migration, we built in a whole host of things to help mitigate downtime, and for the most part, it's taken care of. The next one, though, is a bigger challenge that hasn't been taken care of, which is there's a single point of attack. What do I mean by a single point of attack? This is what I mean. I mean a USB stick. Today, what's to prevent someone walking into your infrastructure, plugging in a USB stick, and getting your VMs? Okay, maybe you've done things to harden access. Maybe you're actually in a data center where you've got things locked down pretty well, fingerprint access, CRED access, all of those things. But physical security is sometimes good, sometimes not good. Okay, it varies wildly from customer to customer. So I've seen branch offices where the security for their quote-unquote mobile data center is literally the janitor's closet with a little bit more power and a little bit cooling and a little bit bigger lock. Okay? Well, in the world of virtualization, if I can walk in with a USB key, and by the way, 256 gigabytes, pretty common these days, plug it into a server and start copying your VMs, somehow getting access and copying your VMs and taking them home with me, what's to prevent me from putting this USB stick in my laptop and firing up your VMs, opening them up and getting all of the secrets out? By the way, this is true on any hypervisor, VMware, Hyper-V, KVM, Xen. This is a universal problem. And it fundamentally goes to the fact that A, the VM has no idea to figure out, am I running on the right hardware? Am I running on trusted hardware? There's nothing that prevents an admin from actually finding keys in memory. I've been asked this for many years. Jeff, why don't you put a TPM in a virtual machine? Then we can encrypt it with BitLocker and that will solve all of our problems. Except that it doesn't. Because if I put the encryption keys in memory, guess what? An admin has full access and I can go into memory, I can find those keys, and I can decrypt your VM. Guess what? Problem not solved. So this is a really challenging area. This is an area we've been looking at very closely, and I'm thrilled to say we are introducing a brand new security technology around this called shielded VMs and guarded fabric. Here's what I mean. The first thing you want to do is you want to create a guarded, think of it as the trusted fabric. So here, for example, I've got some servers, I've got some storage, I've got some networking. And these servers, right here, I've got 3 servers, let's say. Guess what? These servers are part of my Contoso.com fabric. This is my corporate fabric. At the same time, I've got a separate service called the Host Guardian service. I want to be very clear, this runs in a separate trust domain. Okay? The Host Guardian service is actually telling the guarded fabric, yeah, this is an attested fabric. By the way, the keys are actually held not on the local machines. They're held out here by the Host Guardian service. What this allows us to do is provide a way to encrypt VMs in a way that the host infrastructure, the guarded fabric, doesn't ever see the keys. Now, you create your shielded VMs. And it's just an attribute of the VM. But what this means is this virtual machine can only run on the Contoso.com fabric. If I take that VM, I stick it on a USB key, take it home, guess what? It's not part of the Contoso.com fabric. I have an encrypted blob. It cannot run. Think about this for a minute. This is incredibly valuable. Now, even a local admin on those servers cannot see into those VMs. So, shielded VMs can only run in fabrics that are designated as owners of that virtual machine. So these VMs can only run on Contoso.com. It also prevents against the rogue admin. Okay, there have been cases where, you know what, we trust our admins, we trust them all, but you know what, sometimes they have a bad performance review too. And you know what, this admin may be upset and angry, and before he walks out the door tonight, he's going to stick a USB key into his server, he's going to grab a whole bunch of VMs, and he's going to pour through the company secrets, and he's going to do things to embarrass the company or organization. Now, we all wish this doesn't happen, but it does. What you can expect with shielded VMs is you do get the functionality that you expect to use. Live migration, storage migration, that all continues to work. But the ability to actually double click on a VM and remote into it, you don't get console access into that anymore. You need to RDP into it. You don't have the ability, for example, if I live migrate it to another server that's not part of the shielded fabric, guess what? Nope, it's not running there because it's not part of the shielded fabric. And most importantly, if the rogue admin takes VMs home on a USB key, sticks them in his laptop at home, tries to open them, tries to mount them, tries to start them, tries to decrypt them, they can't. Because that laptop will try and talk to the Guardian service, and even if it can talk to the Guardian service will say, I don't recognize this system, you're not part of the Contoso fabric, this VM can't run. So this is a great example of the work that we've been doing to really help secure data center infrastructure as well as your virtual machines so they can only run in your organization. Now, we do this through a variety of different technologies. First one is something called virtual secure mode. As I mentioned before, you may have heard me say, well, wait a minute, the admin can't actually get access to the keys. You were thinking, how is that even possible? Because today, if I'm admin on the machine, by definition on any system, if I'm admin, whether this is Windows Server, VMware, Linux, you name it, doesn't matter what OS it is, if I'm admin, if I'm root, I am God and I can do anything. Well, virtual secure mode actually doesn't reside in the context of the Windows kernel. It actually resides in a separate little tiny enclave off to the side of the Windows kernel. So the Windows kernel doesn't even know that virtual secure mode exists and that the keys are running. And inside there's a teeny tiny little kernel that just manages the keys. It's also, we're providing this guarded fabric through the Host Guardian service. And that helps us to identify the legitimate hosts and certify them so they can run virtual machines. And then finally, we are putting a virtual TPM into the virtual machine, but as I mentioned before, in and of itself, that alone does not solve the problem. However, by putting a virtual TPM into the VM, we can now run things like BitLocker as well. The important thing to point out here is no single one of these things will solve the problem. If you only do one, I can break through another door. You have to do all three. No one else has this technology, and this is something we've been very much focused like a laser because customers like you have told us, how can we better help ensure that our VMs don't walk out the side door, and even if they do inadvertently, even through just a simple mistake, how can we make sure that the bad guys don't get important company information? Next, I want to talk about our next generation application platform. Now, I'm not going to spend too much time on this because I know I'm going to be running short of time just a moment here. But one of the things I want to talk about is a hot new technology over the last year and a half or so, containers. If you've heard the word Docker or if you've heard the word containers, you've probably been wondering, what are these about? Well, containers are a technology that exists. It's an abstraction. It's a type of virtualization. One of the big challenges we've had with containers, honestly, is trying to kind of walk through all of the misinformation that's out there. I've heard lots of crazy statements. Containers are going to kill VMs. VMs are going to kill containers. Get your chocolate out of my peanut butter. Get your peanut butter out of my chocolate. What's going on here? The important thing to understand is containers and VMs, they're both fantastic technologies. They both have fantastic places, and in fact, they can work together as well. But the important thing to point out is they very much have differences in pros and cons to each. In the world of a virtual machine, we actually create a machine in software. We actually create a virtual motherboard with virtual storage, networking, compute, memory, and things like that, so that you can install an x86 operating system on that and simply run it without the operating system knowing that it's running a virtual platform. A container is a much higher level construct than that. It's a much higher level abstraction. It's essentially where you've abstracted away user mode and you're actually sharing a common kernel. So there's no virtual machine per se that you're running. You're actually sharing a common kernel, and you can have many containers running atop of the same common kernel. But there are differences between that. And what this means very quickly is, in the case of Hyper-V, for example, if I want to run Windows 3.1, DOS, Windows 98, Windows NT, 2000, XP, 2003, Linux, Red Hat, Debian, Ubuntu, I can fire up all of those virtual machines and run that on Hyper-V. And it all just works. And each one of them is isolated through hardware in a virtual machine on top of a Hyper-V. In the case of a container, if I fire up a container, each one of those containers is running atop the same kernel, and in our case that would be Server 2016, because we are introducing Windows Server containers. Now, containers, for the most part, have been part of the whole DevOps movement. It's about easily packaging up an application and all of its components in a way that I can easily iterate, easily develop. I don't have to worry about writing an install or actually just deploy a package, deploy a container, and allows me to do this in a very much more agile method. So containers can run on physical, they can run in virtual, you can run these things together. But one of the interesting things that I mentioned earlier is this whole agility model. So what does it look like from the whole development standpoint? Well, developers build and test their applications in containers. Then they will deploy these and they will push these to some sort of central repository. These could be public repositories like GitHub, or they could be repositories within your organization that aren't public. Then operations will automate and deploy those packages and monitor those applications that are coming out of the central repository. And in fact, they can work back with development to say, look, we found out that from a performance standpoint, it seems like we could actually improve performance. As we're monitoring it, there's things we could do. Development can easily push out a new package, a new container, and something that is usually requires setting up installers and patching is done in seconds because you're literally deploying a new container. You stop the old one, start the new one, and you're ready to go. So it's about enabling this DevOps mentality, this DevOps agility, and allowing IT and developers to work closer than ever before to actually deliver these solutions faster than ever. And containers are a fantastic construct for developing your next generation cloud services. So when we think about containers, you probably hear the word Docker used quite a bit. The guys at Docker are great. In fact, we've been partnering with them very closely for a very, very long time. Containers are a feature of the operating system. Linux has these, Red Hat has these, SUSE has these, but what Docker delivers are the tool sets to help manage, create, and manage the whole life cycle of containers. Well, the Docker tools are ubiquitous, and we want to make sure that Windows Server plugs right into those. So for example, if you're used to your Docker tools today, guess what? Those same tools work with Windows Server containers as well. So if your developers are already doing that, guess what? We're going to make it easy to just plug server containers in there as well. Now, one of the things I want to quickly mention from an isolation standpoint is I mentioned that containers have a shared kernel, which is a pro and a con. On the pro standpoint, it means I'm running very, very fast. If I'm running on the bare metal, there's no virtualization involved. In fact, you'll hear developers commonly say that if they're running a container on bare metal, just how crazy fast it is. But at the same time, there's also concerns around compliance and regulatory. So for example, in the world of compliance and regulatory, the word shared, as in shared kernel, is actually a bad word. They don't want to hear that. In the world of compliance and regulatory, like PCI and compliance, they never want to hear that you have shared resources. We've actually reached the world where they like virtual machines because they know that they're hardware isolated, each independently in their own virtual machines, running in their own OS with their own operating system resources. So the whole notion of a shared container is kind of something that causes concern. We wanted to make sure that containers are just easily deployable, and we want to make sure that we alleviate any of those concerns. So the way we've done it is we've actually generated a second type of container. That's called the Hyper-V container. And the good news is for the developer, you don't have to change anything. The important thing is if you write a container for Windows Server, whether it's a Windows Server container or a Hyper-V container, it's exactly the same. When you actually deploy it, think of it as checking a checkbox. Do I want this to be a Hyper-V container or a Windows Server container? If it's a Hyper-V container, we will put up our Hyper-V hardware isolation around it so that we provide this extra level of isolation, and you're actually not sharing resources like you would with a Windows Server container. Windows Server containers are great. You can use them in test dev. You can even use them in production, even in your own enterprise where it's hardware and metal that you want to do. That's fantastic. But in a public cloud environment, you're going to want to do that in the auspices of a Hyper-V container because we're going to give you that extra layer of protection. So finally, what's going to run in a container? Well, this takes us to kind of where our server journey is. Where in the last couple of releases we've had Windows NT 2008, 2012, and you'll notice over the releases we've been componentizing Windows Server, making it smaller and making it being able to componentize and run it the way you want to deploy it. In 2016, we're introducing Nano Server. We think of it as just enough OS. It's optimized really for cloud infrastructure, so you can run this on your hardware, for software-defined compute, for software-defined storage, for Hyper-V or scale-out file server. It's got full Windows driver support and an optional anti-malware package as well, because we know for compliance and regulatory, a lot of times they require that you have an anti-malware package, so that's there as well. It's also ideal for next-generation distributed applications. So as you start to write for containers or applications in VMs, and you want to use things like IIS, DNS, Core CLR, ASP.NET, Node.js, all of these things, guess what? Nano Server is the ideal way to do it. And from a footprint standpoint, the realization is amazing. If you look on the far right, today the full stack of Windows Server 2000, the full stack of Windows Server, it's about 4.5 gigabytes. If you look at Server Core, it's a little over 2. It's about 2.1 gigabytes. If you look at Nano Server, the footprint today, the latest numbers I looked at, it's 147 megabytes on disk. That's a dramatic refactorization and componentization of Nano Server. And so we want to make it easy. We want to drastically reduce the resources as well as drastically reduce the reboots. If you'd been running full server over the last 12 months, you rebooted your server about 24 times. If you use Server Core like we recommend, you rebooted your server 11 times. If you'd been using Nano Server, you would have rebooted your server 1 time over the last 12 months. That's where we're going with Nano Server. And finally, just to wrap this up, from a management standpoint, of course, you can use the things that you're used to, but in fact, we're also making it easy to do it from this nice, easy to use, remotely managing Nano Server console through the remote server management tools. And you notice this looks suspiciously like Azure Stack. It uses a common framework. It's not Azure Stack, but this allows me to manage Nano Server remotely, because you're not logging into Nano Server. There is no local experience. What we're doing is we're giving you that local experience remotely so that it's easy to be able to manage through RSMT, and you can do things like bring up Task Manager, start and stop processes, look through Device Manager, all of these things. So again, there's a tremendous amount of capabilities we're delivering in the data center, in your infrastructure that you're going to be able to take advantage of in the 2016 wave. With that, I would highly recommend that you evaluate Windows Server 2016 and System Center 2016. The bits are publicly available right now in our technical previews. Check out the scale-out file server, Hyper-V, containers, PowerShell. Didn't even get a chance to talk about that, and PowerShell DSC, and so much more. And of course, shielded virtual machines, incredible capabilities that are built into the box of Server 2016, as well as Azure Stack TP1 that's available now. So thank you guys very, very much. I appreciate your time. And I think I'm going to wrap it up and head on over and see where we're doing in terms of questions and check out your Q&A. Thank you guys very much and enjoy the rest of the conference.
Wow, what an awesome job. Thank you so much, Jeff. And as Jeff joins me in my little cupboard here, let's just quickly recap what we've got and what we've seen from Jeff there. He covered a huge amount of stuff from virtualization, storage, networking, Storage Spaces Direct, Hyperconverged, shielded VMs, Azure Stack, Nano Server. The list goes on and on.
Yes.
Thank you so much for that.
My pleasure, Matt. My pleasure. Anytime.
You were the first on my list when I wanted this session delivering. I thought, who could do a great overview of everything that's going on in the data center? I thought of you, man.
Thank you.
Awesome job. No worries. So we've had some questions coming in, a few related to Windows Server, a few related to Azure Stack and stuff. We'll go through as many as we can. For you, if I had to put you on the spot, if you had to choose your top one feature in Windows Server 2016 specifically.
You're killing me.
I know. For IT pros, what would be the thing for you that excites you the most about this? What's fundamentally changing the game for us?
All of it?
All of it is not acceptable.
No, you're killing me. It depends on who I talk to. The first thing that resonates with a lot of people that I talk to is the scale-out file server, because they look at it and they go, wow, I truly see the Azure learnings in the way you architect Azure storage being delivered in Storage Spaces Direct. And the idea of not having to deal with shared SAS and just literally servers, disks, and Ethernet. And you're going to just manage all of this for me. And basically the way Storage Spaces Direct works is just like in Azure, we write to 3 locations simultaneously. So in Azure, we detect, hey, you know what? If one of these writes didn't work, or a disk went down, or a fault domain went down, we detect it and start writing to a 3rd location. That intelligence, that architecture, that insight has been brought into Storage Spaces Direct, and customers love the fact that, oh my gosh, with the price point of SSD, with the work that's been going on with tiering and deduplication. In fact, deduplication is another example of something I didn't get a chance to talk to about. But in deduplication, you're going to see a massive performance boost from 2012 R2 into 2016.
Using more of the cores, using more of the system. Yeah.
Deduplication is now fully, it massively scales to how many cores you got in your box, and we will start scaling and deduping, and it just radically improves your performance. And the amount of performance really is how many cores you have on your machine. The more cores you have, the more we'll take care of it, and the more we'll dedupe faster. So storage is something that continues to pop over and over again in Storage Spaces Direct. I didn't get a chance to talk too much about the work that we've done in Hyper-V, but a bunch of the features that people have long requested, like the ability to hot add memory, is in there.
Hot add NICs.
Hot add NICs is in there. For the first time ever, you can hot remove memory. This is actually something that's been requested before, but a lot of people have just come to the realization this is something that's really, really hard. And it is really, really hard. It's work we actually had to do in the kernel and in the hypervisor to enable it. But for the first time ever, we actually can take away memory from a virtual machine while it's running.
But not beyond what it's using at that time. It's intelligent enough to know.
It is intelligent, of course, but at the same time, we're delivering some really requested features that have long been on our feature list for Hyper-V, and being able to do things like that.
So one thing I really like about Hyper-V in this release, PowerShell Direct.
Yes.
Very handy, very useful for just those administrative tasks where I just need to throw something into a VM, copy a file, those kind of administrative tasks that mean I don't necessarily even need a NIC. I can just get into that VM using the integration.
So we have to talk about this. So again, I got to the end, and I again mentioned that I did get a chance to talk about PowerShell, but this to me is absolute killer feature for IT pros and developers. Think about this for a moment. Today, if you're developing on your laptop, or if you're an IT pro and you're setting up work on your laptop or creating a VM or a container, today you've got to, I've got to set up networking, I've configured networking, I've got to set up shares, or I've got to do, wouldn't it be great if you could actually sit on your laptop and actually PowerShell right into a container, PowerShell right into a VM? Don't set up a NIC, don't set up a network, don't need to do any of that futzing around. Literally, I'm PowerShelling right into to a container or VM. That is in 2016. If you're a developer, an IT pro, and we've been telling folks, the importance of PowerShell. Wow, we just made it, 10 times easier to be able to use PowerShell now in these environments. And we want to make sure that for developers who are using containers, gosh, we made it so much easier. I mean, don't futz around with NICs, just do what you need to do. So that's a critical feature that we're delivering through PowerShell that Hyper-V is taking advantage of.
So just to view some of the, or go through some of the questions that have come in around, we'll start with storage actually, since we just covered it a minute ago. So can a 2-node cluster in a box, CIB, with single JBOD be a hyperconverged platform for storage spaces direct? So can a 2-node cluster in a box with single JBOD be a hyperconverged platform for storage direct?
So we have done the work to make 2-node work. And I believe the answer is yes. I would need to go double check with some of the guys that are actually working on this.
Right.
But yes, we
so
actually...
You're not on camera or anything.
Right. But no, we actually done the work because this was something that was requested, having a 2-node configuration available. So yes, that's something we've been hard at work on, and I would recommend keep an eye out for... Keep an eye out for our storage blogs, because this has probably been probably one of the areas that's been talked about a lot, which is how small can we get? Can we do branch offices with like 2 or really 4 nodes? We seem to be hearing is a real common one. 4 to 6 nodes seems to be a very common one, where we just like to load in a bunch of disks now
within the chassis of the servers.
Within the chassis of the servers, not have to deal with even shared SAS even at that level. So that is an area we're spending a lot of time focusing on from a PowerShell automation standpoint, as well as just from a documentation standpoint, to make that really easy.
And the recommendation for RAID approach for storage spaces, regardless of Spaces Direct or the traditional model that exists today, is still passing through as minimal invasion as possible from any HBAs.
We want it pass-through mode, absolutely. That's because really we need to understand we can't have anything abstracted from us from our view of storage. So using a RAID controller, pass-through mode.
Okay, so that's a little bit about Spaces partnerships with Spaces Direct. So have we got anything we can share with people there? Obviously they could build their own, and you can even do it in VMs if you just want to test it out. But what about in terms of vendors out there who are supporting Spaces in general?
We have a fantastic wave of OEM partners. I'm not in marketing, so I don't want to speak for any or I'll get in trouble. But I will tell you, we have a fantastic partnership, and you can expect to see lots of Storage Space Direct solutions going to be out there. And you mentioned Azure. Funny, but it's true. yeah, you can actually set this up on Azure. We've actually had some people trying it out on Azure coming back to us and goes, we didn't realize we could do this.
Yeah, you just need a couple of VMs with lots of disks, and away you go.
Yes,
So,
you can.
shielded VMs,
Yes.
I think is incredible.
Yes.
Quite complex to set up, but there is
Yeah,
good...
I should have mentioned, yeah, there's some complexity involved because you are going to be dealing with setting up this new notion of guarded fabric, having a separate trust domain for your host guardian service. But at the end of the day, every customer I've talked to says, yeah, I understand there's some complexity involved. I'll get over it because this is about safeguarding my IP of my organization.
Yeah. And it might not be every workload that you run on the guarded fabric. It might be a specific set for compliance reasons or whatever it may be.
Yes.
There was a couple of questions came in with shielded VMs and the guarded fabric. Does it require a PKI?
So let's get into requirements around this. So what the requirements are actually very straightforward. I didn't get it again. An hour flies by, my friend. I'm sure you know this, spending all as much time as you do in front of the camera. But there are a couple of the requirements for shielded fabric and shielded VMs and guarded fabric, and here they are. You've got to have the latest UFI, and I believe it's 2.3.1D.
Yep.
You've got to have the latest UFI version, and in the server, you need a TPM2. Okay, those are your requirements. And I need to be clear, it is TPM2. We looked at TPM 1. Whatever the last version was that were shipped. We tried to make it work, but it was simply not going to work. In the world of servers, interesting thing, TPMs on servers is actually not very common. TPMs are something that have been shipping on phones and laptops and tablets for the longest time. They have not been shipping in servers because honestly there hasn't been a scenario that really called for them. And when we began this work on shielded VMs, guarded fabric, a long time ago, we sat down with all of our hardware partners and we said, guys, we're going to require TPMs. This is super important. Make sure this is in there. And they all came back and they looked at what we were doing and said, oh my gosh, this looks really great. We're excited. And so we know that servers have started shipping over the last few months with TPM2. Talk to your server vendor. Most likely your servers that you have today in your infrastructure do not have TPMs in them. Just to be clear, if you don't have the TPM2, you could technically run shielded VMs and guarded fabric without it. What you lose is you lose the protection against the local admin.
And the code integrity.
Okay, and that's essentially what you're losing. So if you had the latest UFI version, but you didn't have the latest TPM, you didn't have a TPM in it, you could still run the shielded VMs with guarded fabric, but the scenario you lose is where literally you have an admin, a rogue admin, and the ability to protect against them.
Okay.
So, our recommendation is certainly going to be, we want to provide you the best, most hardened security solution. So we are going to recommend both TPM and UFI.
Yep.
And like I said, our hardware partners are jumping all over that.
Okay, cool. So final question, I suppose it's a little bit devil's advocate on the shielded VMs, and don't want to stitch you up here.
No, that's all right. I'll do my best.
What if somebody did have a shielded VM that's protected and it's running great, and you can't console to it because that's disabled? What happens if something goes drastically wrong with that virtual machine inside? You can't RDP to it.
Right.
You can't PowerShell direct to it because that's all disabled. What do I do about that VM?
This is a great question where I would tell you my good friend Dean Wells, the program manager for shielded VMs, would say, we have a solution for that, but I don't want to give you the wrong answer.
Right.
So I know that in the current technical preview for Server 2016. We've got a bunch of documentation written for shielded VMs. I believe the answer to this is up there and it's actually posted either in TechNet or in a blog, and I don't want to give you the wrong answer, so I'm gonna point you to that.
Right.
I'm gonna go look afterwards, and if I don't find it, I'm gonna go make sure that we do have an answer to that. I know that as part of our documentation, as we start to get closer to 2016, I've been in the process of reviewing a bunch of docs, so it's kind of a blur to me right now, and we are releasing more pretty constantly, and we're gonna be doing a lot more of that as we get closer to 2016. But trust me, we definitely have to accommodate a solution where something really catastrophic is bad. How do we deal with a scenario like that?
Nice. So we had a lot of questions, well, not a lot, a few questions on a number of different areas that you touched on, like containers, Azure Stack, OMS. Now, I'm not going to ask you those now because we've got dedicated sessions on those today.
Awesome.
So we've got Joe Chan coming in to talk about OMS
Joe's going to take good care of you.
Exactly.
I wanted to just tee it up for Joe.
Exactly, and then BAT. We've got Rafat on Nano. We've got Taylor on containers. So all of those questions will be covered a bit later on. So I want to wrap up the session. Thanks for your time, Jeff.
Thank you, Matt.
I want to tee up the next speaker. If we could just cut to my screen and show you the question that's ahead of the Nano Server session with Rafat Issa. So the question is, when creating a Nano Server image using the PowerShell to run on physical hardware, this is important, to run on physical hardware, which optional package do you add to the PowerShell creation script? So that's a little trickier than one we asked for Jeff, but remember, answer on Twitter, hashtag TechNet VC, hashtag contest. So that's everything you need to know, and we're handing over to Nano Server now. Enjoy.